Data cleansing. Data cleansing or data cleaning is the process of detecting and correcting, or removing, corrupt or inaccurate records from a record set, table, or database and refers to identifying incomplete, incorrect, inaccurate or irrelevant parts of the data and then replacing, modifying, or deleting the dirty or coarse data. Data cleansing may be performed interactively with data wrangling tools, or as batch processing through scripting. After cleansing, a data set should be consistent with other similar data sets in the system. The inconsistencies detected or removed may have been originally caused by user entry errors, by corruption in transmission or storage, or by different data dictionary definitions of similar entities in different stores. Data cleaning differs from data validation in that validation almost invariably means data is rejected from the system at entry and is performed at the time of entry, rather than on batches of data. The actual process of data cleansing may involve removing typographical errors or validating and correcting values against a known list of entities. The validation may be strict, such as rejecting any address that does not have a valid postal code, or fuzzy, such as correcting records that partially match existing, known records. Some data cleansing solutions will clean data by cross-checking with a validated dataset. A common data cleansing practice is data enhancement, where data is made more complete by adding related information. For example, appending addresses with any phone numbers related to that address. Data cleansing may also involve harmonization, or normalization, of data, which is the process of bringing together data of varying file formats, naming conventions, and columns, and transforming it into one cohesive data set. A simple example is the expansion of abbreviations, street, road, etc. to street, road, etc. Motivation. Administratively incorrect, inconsistent data can lead to false conclusions and misdirect investments on both public and private scales. For instance, the government may want to analyze population census figures to decide which regions require further spending and investment on infrastructure and services. In this case, it will be important to have access to reliable data to avoid erroneous fiscal decisions. In the business world, incorrect data can be costly. Many companies use customer information databases that record data like contact information, addresses, and preferences. For instance, if the addresses are inconsistent, the company will suffer the cost of resending mail or even losing customers. Data quality. High-quality data needs to pass a set of quality criteria. Those include: the term integrity encompasses accuracy, consistency and some aspects of validation, see also data integrity, but is rarely used by itself in data cleansing contexts because it is insufficiently specific. For example, referential integrity is a term used to refer to the enforcement of foreign key constraints above. Process. Good quality source data has to do with data quality culture and must be initiated at the top of the organization. It is not just a matter of implementing strong validation checks on input screens, because almost no matter how strong these checks are, they can often still be circumvented by the users. There is a 9-step guide for organizations that wish to improve data quality. Others include: system. The essential job of this system is to find a suitable balance between fixing dirty data and maintaining the data as close as possible to the original data from the source production system. This is a challenge for the extract, transform, load architect. The system should offer an architecture that can cleanse data, record quality events and measure/control quality of data in the data warehouse. A good start is to perform a thorough data profiling analysis that will help define to the required complexity of the data cleansing system and also give an idea of the current data quality in the source systems. Quality screens. Part of the data cleansing system is a set of diagnostic filters known as quality screens. They each implement a test in the data flow that, if it fails, records an error in the error event schema. Quality screens are divided into 3 categories. When a quality screen records an error, it can either stop the data flow process, send the faulty data somewhere else than the target system, or tag the data. The latter option is considered the best solution because the first option requires that someone has to manually deal with the issue each time it occurs, and the second implies that data are missing from the target system, integrity, and it is often unclear what should happen to these data. Criticism of existing tools and processes. Most data cleansing tools have limitations in usability. Error event schema. The error event schema holds records of all error events thrown by the quality screens. It consists of an error event fact table with foreign keys to 3-dimension tables that represent date, when, batch job, where, and screen who produced error. It also holds information about exactly when the error occurred and the severity of the error. Also, there is an error event detail fact table with a foreign key to the main table that contains detailed information about in which table, record and field the error occurred and the error condition.